Good morning. We're going to try this again. My last one had absolutely terrible sound. In this video, I'm going to go through and try to help you understand what was going on in the week 3 poll questions. So I'm going to skip back and forth a little bit. This question was your second question where I presented a R-based script. We can tell it's R from some of these different tools like this assignment function. The syntax here where I have a function named followed by parentheses with arguments that have these defined commas in between them, things like that. This was a similar script, does a very similar thing, but it was written for the bash interpreter. So this would be an example of a bash script. Now, for the record, all bash scripts are also going to be shell scripts because that is the point of bash. It is a way to communicate with typically Linux-based operating systems. And so, yes, it is a shell script. It is also a bash script. It is not an R script. Now, this example uses a tilde, which stands for the home directory, in order to tell the computer where to make this file that I've called fake file. That is an example of an absolute file path. That this is a specific position within the directory system. And it means that even though our terminals, like there's this concept of a current directory or a working directory when you're more using an R vocabulary. But this idea of the current directory doesn't matter because I am specifying that specifically the home directory is where this should be made. So it doesn't matter where my terminal is currently looking. It doesn't matter if I have permission to write to the current directory. The only directory that would matter here is the home one because it's an absolute file path. Now, for the record, this could have confused people, but this is just a variable. It's just a way of storing this information because otherwise this is a very long piece of code. And it also allows you to later on refer to the URL if you needed to. So it is an absolute file path. It's a specific place on the system. It does not matter where your current directory is. That would be the purview of a relative file path. On the other hand, this one just creates an object at the current directory. So kind of a weird way to describe that as a relative file path, but it's certainly a relative file operation. I don't know. Does it strictly fall under that? I would still say yes, that it is still a relative file path. And I think most people would agree with me. But in the end, like, it's certainly something happening at a relative location depending upon the working directory of R, aka the current directory. So it would require permission to manipulate that current directory. Cool. Not too bad, right? Next question. What is the behavior shown below? So here's the thing we're just going to say 1,000 times in this video. And that is that in order to combine an object, you must have all of the objects be the same type of data. Like that's just because combine puts them into a single object, it has to have some sort of container that can actually hold all of those. In fact, if it still couldn't have figured out a way to combine them, it would have ended up making a list, which a list's properties are just that it can contain multiple types of data. But it doesn't quite have to do that. Ooh, I went out of focus. It doesn't quite have to do that because while I can't turn an A into a number, I can turn a number into a character. So like the concept of 1 can be represented by, this shape, a 1. The concept of 2 things can be combined into a single character, the character squiggle 2. And so on. The numbers can be represented by characters fully without losing any information. But not the other way is not true. Like, well, would I turn A into? Maybe 1. I could understand that argument, but what about lowercase a? Also 1? Well, you'd have lost information. And that's why it's like it goes the other direction. So the answer would be character. This next one has you take that same concept and apply it in a more advanced way. In this case, all of these have to become a character. We've already established that. Yeah, it was a very similar example. All of these have to become an A. Then it tries to convert them into a logical vector, but it turns out that it can't take the the 0 character, and turn it into a logical vector. It just fails, and it turns into an A. It can, however, take the number 0 and turn it into a logical. It turns the number 0 into false. And so that's the difference here. Is the only difference between these two lines of code was that this one, after the combine, became a character vector, and that this one, after the combine, became the same. A numeric vector became a longer numeric vector. That's not actually what this question's asking. It's the answer to the next question. But that gives us kind of the idea that's happening here. I ask you, what function must complete first? And so if I try to read through here, what are the functions? Well, technically this symbol all together, not one or the other. It has to be together like this. This symbol is the assignment function. It takes the object to the left, and that will be actually just used as the name. So it doesn't actually take it as an object, it takes it as a name, and it's going to assign data to that name or identifier. It then takes the values to the right, and that's what it uses as the values for that object. And if there was an object of that name already, it just overwrites it. But that has to occur last. It means that I have to have done all of this first. Okay, well, the as.logical followed by this parenthesis, which matches with this parentheses, has to occur in between. So it's a medium step, but it has to have had the C complete first. So the combine has to have completed in order for as.logical to work. So the answer is the C. Most people got that one right, for the record. That probably didn't help anybody. Sorry. Anyways, this question was not an anyways moment, but this question I had already kind of talked through. This ended up combining to create a character vector. So this was a character 0, not the number 0. And once you try to do the conversion, the character 0 could not make the jump. It couldn't go from the character 0 to a logical value. So it became false. I believe if I had spelled out TRUE up in this top section, it would have been able to coerce into a logical vector, but I didn't do that. The 0, on the other hand, literally the value 0 was able to be coerced. And interestingly enough, 0.5 also coerces, but to a true value. And so what we learn in this example is that any value greater than 0, or at least much greater than 0 from this piece of evidence, and I believe it is just anything greater than 0, ends up being converted into a true. So your answer is just all of these that refer to the characters, because it's not just the A. The A is the ultimate cause. It's the original, I should say, cause. But because that A is there, all of these end up becoming characters, and that's why they all end up becoming an A. This next one has you combine some of that information, namely the fact that 0, 0.5, will become false and true and true and true. But it also has you combine it with this concept of kind of order of operations, as well as this example up here. So this is definitely a synthesis level question. It makes a bit of a jump. But if I break it down step by step, which is the goal, I can read through this first one. It says that if I combine 2 and A into a single character vector, because it would have to be because of the A, and then try to convert them into numeric values, the 2 absolutely works. Someone wrote that in, that works. But the A does not manage to make the conversion. It fails, and so it becomes missing information. That produces this warning message. The second example, the one I'm asking you to interpret, starts off with 0, 0.5, 1, 1.5, but then combines it with a, which means all of these became characters. That's cool. It's true, but it doesn't last for very long because they're immediately converted into numeric values. The 0 becomes 0 again, 0.5 becomes 0.5 again, and so on, but the a still can't make the jump, and so it becomes missing, and that's actually what produced this warning message. So at this point, you have 0, 0.5, 1, 1.5, and missing. That is then applied to the as.logical, where this becomes, what was it? False, true, 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 and missing. Still missing. Does not like get filled in somehow. That's the idea. This next one requires you to have just kind of memorize something, as I was talking very quickly about a lot of class information. But what this essentially is trying to give you clues for are two properties of what's called a data frame. A data frame is a rectangle of data, so it's a table. We can see that it's a rectangle up here. We only talked about two classes of data that form a rectangle. We talked about matrices and we talked about data frames. Well, a data frame is a type of list and is a class of list type. A list type object is able to hold multiple types of data. Like that's their whole thing. They allow you to combine multiple types of data into a single object. Now they're kind of stored separately. In this case, I've been calling them containers. So I said like a data frame is like a list, but each of the containers has the same size. That's what allows you to organize it into a table. But that's it. Two properties. First one, it is a rectangle. Second property, it contains multiple types of data. And that's how we know it's a data frame. Now this next one, I did notice in my last attempt to make this video that a comma just got cut off here. So there should have been a little comma right there because the combine function takes two separate arguments. So I just wanted to point that out. I'll have to go edit that in later. But you take this object, you make this object from the output of this combine, which is combining two random sets of data drawn from two different distribution models. One, the uniform distribution, which is what it sounds like. It's a distribution where it's just all the same. So we can clearly see that occurring throughout this region. It starts at 0, it goes to 100. There's a bump in it, but outside of that bump, it's fairly uniform. So that's just going from 0 to 100, fairly straightforward. Our norm is the normal function. It is drawing from the same number of values, so 100,000 values. That's how many little data points it's generating. The mean, I can see right here, is going to be somewhere around 25. The standard deviation is 5. And what's interesting is you can see that because there's 100,000 points, it's got a pretty good distribution, or it matches like the normal distribution. It's a nice bell shape. You can't really see it right now because the the uniform distribution is on top of it. But if I try to measure it out, so about 15 values away, so around here, away from the mean, I can see that the distribution probably has cut off pretty strongly. And that matches what we know about normal distributions. As around 3 standard deviations away, you've really reduced quite dramatically the total amount of data. If you don't know that yet, you probably just haven't looked at some of the statistics and remember some of the values, like 2.98 standard deviations away comprises a very large proportion of the data. But that's normal versus uniform. Finally, this last break was the second argument in histogram. Neither one of these arguments were named, which just means it's going to be based upon the order in the documentation, which makes object 5 the x And the second blank will have to be applied to Sturgis. Well, to breaks. Sturgis is the default value for breaks, but you've seen a few examples of HIST in my class. HIST has really wide bars by default, but here I've made them very, very tiny, which is fine because this is a ton of data. It's 200,000 data points, so it can be fairly small bins. It's also truly continuous data. There's no like gaps because of whole numbers being needed. So anyways, I must be using one of these types of breaks. In this case, I am providing a single number giving the number of cells for the histogram. And the only way you would have really known that is that I limited your options. So this was 1,000. The mean was 25, the maximum was 100, and the minimum was 0. So this next section was taking kind of what's going on next in this class. I mean, really so far we've been really focused more on the syntax of R, giving you access to some of these definitions, but it's not really doing coding. It's not really making a lot of like logical decisions and doing an analysis and changing behaviors of an analysis based on a comparison. That's really what we're building towards. That's why this is a powerful tool. And so I had some of these looking ahead questions just to help push us down what I think y'all have enough tools at this point to start accessing, but we just haven't had time to cover yet. So this next section is starting off with a less than symbol combined with an equals symbol that actually combines to make a single operator, which is just like a symbol-based function. That compares the values to the left to the values on the right and does logic. Since the values to the left are just 1, 2, 3, 4, 5, the value to the right will be compared. Now, one thing to keep in mind is that they are recycled when needed. So a 3, just 1 3, is not sufficient to compare to 1 through 5. So it just keeps repeating that 3 over and over. That's the concept of recycling. That one's fairly straightforward. It becomes true, 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 false, false. I think most people got that one right. If you didn't get it right, you probably just forgot that equal sign. Ooh, wrong window. All right. The next question has you look at the a combination of the same kind of range, but this time doing an extraction using the output of that previous section. So I'm tracing my cursor across this region on the right. And you may not realize this yet, but part of the reason why I've been kind of emphasizing, let me take my cursor off the screen. The part of the reason I've been emphasizing the order of operations is as we get deeper into this, like your eye learning to track these order of operations really becomes a literacy skill. Like it's very much a part of just getting better at reading this code. Since I've been doing this for years, whenever I look at a piece of code, I know immediately that I'm like, cool, what happens here? Then we'll combine these, then this goes, and finally I can apply it to the code inside of this parenthesis. But that takes a while to develop, so don't get frustrated there, but do start trying to predict the order of operations, just cognitively, like think through it each time. This had to happen first because it's in parentheses, that's clear. And then before I could do the extraction, it must have been compared to the 3 because look, that's the other side of the extraction. So here this will have become true, true, false, false, false. You'll notice I dropped the equal sign. Didn't really try to trip people up, but I think I tripped a good number of people up. So this will become true, true, false, 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 three falses. This is 1 through 5, and so therefore the 1 and the 2 will be extracted. Now, if I look at these examples, just to keep going through them, this is going to, instead of using a logical-based extraction, so this actually, even though they are made of numbers right now, it resolves to logic before the extraction occurs. So it's an example like more like this one than it is like these. These, though, are using the index position. So this is going to extract the third position from letters, so the letter C. This is going to extract the first, second, and third values from letters, so A, B, C. This one has true, true, false, false, true. So the first, second, and fifth positions will be extracted. Those corresponded to 1, 2, and 5. Anyways, this one we've already answered, just 1 and 2. The next question, as you continue to put these through, it does do a little bit fancier because it has 2 extractions. The, I guess, leftmost extraction is for first extracting the letters 5 through 1. So E, D, C, B, A, in that order, are going to be extracted. And then from that output, notice it's all in parentheses, it will then extract the first and third value. So the first value was E, and the third value was C. I believe this is the last one. On the left side, we have the values 1 through 5. And then the extraction is true at the third and the fifth position. So that should just be 3 and 5. That was pretty straightforward, actually. I should probably scroll that one up. It's a little bit easier than the rest. All right, I do hope that helped. Please reach out if that's not making sense. We're just going to keep practicing these, but soon we're going to move into a second dimension of extraction, and that makes it way more complicated. So definitely practice these if you are struggling. Try to think through it. Remember, break it down piece by piece. One thing I do want to emphasize is that you can just write these yourself and try and figure them out. So like, if I run this line of code, I can see that these do resolve to numbers. The clues are in how R prints it. If I compare them, I can see that R prints it in 2 very different ways because they're different classes of object and different types for that matter. So you can just go through and do these on your own. I think I will post these to the description in some way. I might just make it a downloadable file, but hopefully that video helps. Thank you guys. Have a good day.